Sometimes ago, I didn't really know I would have a friend in you. Sometimes ago, I didn't really know you would never wanna leave me. Sometimes ago, I didn't really
As we've all joined back now,
not
let
to
us
know.
ensure that there's decorum as we go over the topic for today. And the topic is set theory. Set theory. So, like mentioned the other time, set is a collection of well-defined objects. Set is a collection of well-defined objects or elements. I'm still hearing background noise from one of you. I think the background noise should be reduced. So set is a collection of well-defined objects or elements. If you've ever heard before that you're talking about a particular set from a school that graduated from a school, let's say 1999 set, 2015 set, 2021 set, or even 1948 set. We're talking about people that are in the same level. So with that, we're going to look at examples of sets. Examples of sets. And example one here. Somebody is trying to put it on speaker or something, it's vibrating back, so you remove that, please. So example one here is a collection of kitchen items. A collection of kitchen items, and this could include, you can see spoons in kitchen, plates, pots, things that belong to kitchen, knives, and so on. That you can see in the kitchen. If in this set, if I put books, book does not belong. So it won't be a collection of words. I'm still hearing some vibration. Number two example is a collection of classroom items. One of you is trying to put it on speaker and it's vibrating back, it's reverberating. So you have to remove it from speaker if you are the one. Otherwise, it will be detected and the signal will be removed. So a collection of items in the classroom. Books, chairs, tables, birds, and so on. Things you can find in the classroom. So those are well-defined sets. Third example here is a collection of English alphabets. And this ranges from A, E, C, D, etc. So on till Z. So with this, you are familiar with what a set means. It could be the collection of months of the year, it could be the collection of even numbers, odd numbers. These are sets. So very quickly, I'm going to be sharing the documents in this lecture that will tell us more about set and set notation. So are you through with what is on the screen now?
Yes, sir.
Ira, are you through?
Yes, sir.
Ezekiel, are you through?
Yes, sir.
That's it. So I'm going to be sharing another screen with you now, which will take us into the notes that we have to explain. Yeah, what you can see here is set notation. Set notation. What do I call it?
Set notation.
Yeah, set notation. So for the set notation, uh, these are notations that are used to define. These are notations that are used to define the elements and properties of set using symbols. We have some symbols that we use in sets. Those symbols are known as set notation. Symbols save you space when writing and describing set. That's the use of set notation here. And set notation also helps us to describe different relationships between two or more sets using symbol. You might not put all this down, please. The note is going to be available for you later. So please listen so that you can ask questions where it is not clear to you. Is that taken by all of you?
Yes, sir.
Very good. So set notation is when I'm talking about notation, I'm talking about symbols, I'm talking about diagrams. So I'm going to be showing you some symbols, some diagrams now that are going to be leading us into what we have to say. So set notation, like I said, is used to describe different relationships between two or more sets using symbols. And in this way, we can easily perform operation on sets, such as union of sets and intersection of sets. So you can never tell when set notation will show up. It can show up in any topic like algebra, and so you need the knowledge. Now, in a nutshell, what is set notation? Yeah, set notation is a system of symbols. It's a system of symbols, and these are the meaning of the symbols here. Let's look at the meaning one by one. When you see something that looks like this E, can you see this one?
Yes, sir.
That means if something appears like this, that means that thing is a member or is an element of a set. That means it's a member or an element of a set. Then, if you see the same symbol crossed down, it means it is not a member or it is not an element of that set. And when you see this third symbol that looks like a bracket, that means we are talking about a set. We're talking about a set. Then, if you see such symbol like this, it means such that or means for which. If you see something like a ratio or colon, it means such that also means for which. Okay, we're going to look down more now and see how we read and write set notation. Now, to read and write set notation, we need to understand how to use symbol in these cases. Number one, denoting a set. What do I call it?
Denoting a set.
Denoting a set. So, talking about denoting a set, conventionally, we denote a set by a capital letter. By what?
A capital letter.
So if I want to represent a set B, should I use small letter B or capital letter B?
Capital letter B.
Aha. And we denote the elements of the set by lowercase letter. We denote the elements of the set by what?
Lowercase letter.
Yes, very good. We usually separate the elements using commas. How do we separate the elements of a set?
We usually separate it using
For
commas.
example, we can write the set A, capital, that contain vowels of the English alphabet as follows. Can you see it?
Yes, sir.
So set A contains English alphabet vowels. So how do you read what is in the picture? We read this as the set A containing the vowels of English alphabet. Read that, let me hear you. The set A.
Set A containing the vowel of the English alphabet.
Very good. And what is it? This is the picture that you are seeing. Set A that contains. What are the vowels? A, E, I, O, and U.
Oh, U.
Very good. So the next thing is membership of a set. What do I call it?
Membership of a set.
Yeah, set membership. We use the symbol this that you have seen above to denote that something is a member of a set. Are you getting that?
Yes, sir.
You know, when I started, I used kitchen items. Yes or no?
Yes, sir.
So I can say, I can put knife here, and I put E, and I say it's a member of B, where B are the set of kitchen items. Is that taken?
Yes, sir.
Then I can put book at the in the place of 6, and I put this other symbol that it's not a member of a kitchen item. Is that taken?
Yes, sir.
So for example, if B equals to 1 to 5, if the elements of B are 1, 2, 3, 4, 5, then excuse me, then I can say 1 is a member of B. 1 is an element of B, and 6 is not an element of B. Can you read that, please?
1 is an element of B.
6 is not an element,
of B.
and that is the symbol that is here. So I might not write all these wordings. I might just put 1EB, that is one element B, or 6 not element B. Is that taken?
Yes, sir.
Okay. Now, since 1 is an element of set B, we write 1 element B, and it reads 1 is an element of B, or 1 is a member of set B. Since 6 is not an element of set B, we write 6 not element B, and it reads 6 is not an element of set B, or 6 is not a member of set B. Now, specifying members of a set, that's the next thing. What do I call the next thing?
Specifying member of a set.
Specifying members of a set. Now, I can say, we can describe set B above. We can describe the set B that we see above. That set, we can say, B is a set which is equal to, are you listening?
Yes, sir.
So B is a set which is equal to X, such that X exists in N. Can you see this N?
Yes, sir.
And X is less than or equal to 5. X is what?
Less than or equal to 5.
Or I will say B is a set such that B contains X, such that X is a member of natural numbers, and X is less than or equal to 5. So all these things that I have read, that I have written in this straight line, it is simply referring to these sets that you see here. Is that taken?
Yes, sir.
Very good. Very good. So now, I think Said left, want to join back now. So now, let's see. We can describe the set B using this. And how do we read this? He said we read this notation as the set of all X such that X is a natural number less than or equal to 5. Now, you will read with me what is in the pink, and that what is in the pink is read as B is the set of all X. Say that, please. B is the set of all
Is
X
the set of all X.
such that
X
is a natural number
is a natural number
less than or equal to 5.
less
less than
So
or equal to
maybe
5.
we can stop there, and I will start asking you questions. But we'll move forward a little bit, because I will write a statement now, or I will just write in symbol notation like this, and I will ask you to read like this for me, or to tell me what it means. So you need to be familiar with that. Is that taken?
Yes, sir.
Now, what's the next thing we want to look at? Subsets of a set.
Subset of a set.
Now, in your own way, you need sub of a set. That means part of a set. We say that A is a subset of B when every element that A consists is also an element of B. Let me repeat that. Set A can be a subset of set B when every of elements in A are present in set B. We can also say that set A is contained in set B. Do you get that?
Yes, sir.
I said, do you get the explanation now?
No, sir.
Yes, sir.
Okay. Somebody is saying no. Well, read the topic. The person that said no. What is the topic that we are looking at now?
Subset of a set.
Very good. What does subset mean according to what I explained? I said it means part of a set. Let me hear you say that.
Part of a set.
So, what is part of a classroom? It is something that is inside the classroom, yes or no?
Yes, sir.
Now, we can say that set A is a part of set B when every element of A is also in B. Can you repeat that?
Now we can say that set A is a subset of set B when every element of A is also an element of B.
So, is that clear to you now?
Yes, sir.
Very good. Okay, let me ask this question. What if set A have numbers like 1 to 5 and set B have even numbers from 2 to 10? Can we say A is a subset of B? Both of you, yes. Can we say A is a subset of B? If A consists
No.
of number 1 to 5 and B consists of 2, 4, 6, 8, 10, can we say every element in A is now in B?
No.
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 So that means it's not a subset. So before we can say a set is a subset of another set, every element in that set must be present in the main set. Is that taken now?
Yes, sir.
Very good. So, Ire, you did not answer. Is that clear now?
Yes, sir.
So, A is a subset of B is written with this symbol. Can you see the symbol now?
Yes, sir.
So, they might not write this A is a subset of B or A is contained in B. Once you see this symbol, that is the meaning. Is that clear?
Yes, sir.
Now, the symbol this stands for, the symbol like C underline stands for a subset or contained in. So we usually read A symbol C underline B as A is a subset of B or A is contained in B. So we use the notation below to show that A is not a subset of B. That means we are going to cross that symbol. Do you get that?
Yes, sir.
Now, let us assume the one I gave you, the example I gave you. Let A be 1 to 5 and B be 2, 4, 6, 8, 10. Which of the symbols are we going to use between A and B? Is it the first symbol or the second symbol?
Second symbol.
Yes, because A is not a subset of B. That does not mean there are no intersection between them. There could be elements that are present in the two. Do you understand?
Yes, sir.
Very good. Now, proper subset of a set. What's the next one that I mentioned?
Proper subset of a set.
Very good. Proper subset. So let's look at that. We say that a set is a proper subset of a set A is a proper subset of set B when every element of A is also an element of B. But there is at least one element of B that is not in A. Let me repeat that. We say that set A is a proper subset of B when every element of A is present in B, but there are some elements of B that are not in A. For example, if set A is 1 to 3 and set B is 1 to 5, are you listening to me?
Yes, sir.
Set A is what?
1 to 3.
That is 1, 2, 3. Set B is what? 1, 2, 3, 4, 5. So every element in A is in B, yes or no?
Yes, sir.
But what are the elements in B that are not in A?
4.
4 and 5.
Five.
Now you are getting it. So we can say set A is now a proper subset of set B. Is that taken? So
Yes,
we
sir.
Yes, sir.
use the same symbol this as a proper subset, but there is no underlining. Okay?
Yes, sir.
So now you know the difference between when it's underlined or when it's not underlined. Now, the symbol C stands for proper subset. Therefore, we read A, C, B as A is a proper subset. We refer to B as the superset of A. The figure below illustrates A as a proper subset of B and B as a superset of A. So once B swallowed up A, then B is a superset of A. Look at it. This is the symbol. Are you getting that now?
Yes, sir.
Every A is in B, but not every B is in A. You get that? Very good.
Yes, sir.
Now, the next thing we are going to look at today, and probably we might round up or we look at one more properties of set, is equal set. What do I call it?
Equal set.
Now, if you graduated from whatever college and another person graduates from whatever high school, but they are both GSS3 graduating GSS3 to SS1 to SS1, then we can call you equal set. Yes or no?
Yes, sir.
So you are not in the same school, but we can call you equal set. Now, if every element of set A is also an element of set B, and every element of B is also an element of A, then we say set A is equal to set B. You get that now?
Yes, sir.
Yes, sir.
Every element that A has is also every element that B has. Then we say set A and B are what? Equal. So we use the notation below to show that two sets are equal. A equal B. Okay?
Yes, sir.
Set A is equal to set B. Or we say they are identical sets. What can we call them again?
Identical sets.
Very good. Now, what's the next thing to talk about?
Empty set.
The empty set. The empty set is a set that has no element at all. Read that.
The empty set is a set that has no element at all.
So if it doesn't have any element, then why is it a set? Anyway, we can also call it a null set. You can call it what?
A null set.
Null set. So we denote by symbol circle, slash, or by this bracelet. Okay?
Yes, sir.
So that is how to show an empty set. An empty set. Then it is also good. Read this, please.
It is
So,
was nothing.
Nothing.
The empty set.
of every
Nothing.
set.
That the empty set is a subset of every set.
Of every set.
Once it doesn't contain anything, then we can see it in every set. Do you understand?
Yes, sir.
Now, the next one to look at is called singleton. What do I call it?
Singleton.
Singleton. Yeah,
Singleton.
Yeah, a singleton is a set that contains exactly one element. When I mean one element, what did I mean? I mean one object. Okay?
Yes, sir.
Due to this reason, we call it a unit set. We call it what?
Unit set.
So, example, the set 1, maybe ordinary 1, contains only one element. So, it's a singleton set or a unit set. Now, this is a very important set to note. Universal set. What do I call it?
Universal set.
Universal set. Yes. Talking about it, I can't hear from Said at all. He's not joining with his audio and video. I don't know what is wrong. Maybe I should remove him, or if I hear from him, maybe I should remove him, then he will join again. Now, the universal set is a set that contains all the elements. Say that, please.
Universal all the elements.
Elements under consideration. Okay.
Yes, sir.
So if there are some elements that we are considering and some part of the set have it, some doesn't have it. When we are talking about universal set, we must talk about a set that consists of all of the elements under consideration. Ire, can you sit up, please? Ire, your class is being recorded, your class is being monitored. So you see, conventionally, we use the symbol U, a long U, to denote the universal set. Is that taken?
Yes, sir.
Very good. Then the next thing to talk about is the power set. Is the what?
Power set.
You know, we mentioned superset above, yes or no?
Yes, sir.
Okay. The power set of set A. Listen, please. I'm hearing some maybe closing of whatever there, I don't know. The power set of set A is a set that contains all subsets of A. We denote a power set by P into A, and it reads as power set of A.
Of A.
So P into A read as what? The power set.
Power set of E.
Now let's talk about the next one, which is the union of sets. What do I call it?
The union of sets.
The union of set A and set B is that set that contains all elements in A or B, or both A and set B. What we are trying to say is that if you gather all the elements in A and all the elements in B without repeating anything, then we call it the union of set A and B. Is that taken?
Yes, sir.
So we denote A and B union. We denote the union by writing A union B as AUB, and it reads as what? A union B.
Union B.
We can also use the set builder notation to define this notation of union as below. We can say that A union B. A union B is a set of X such that X exists in A, or X exists in B, or X is both a member of A and B. Please listen to this and you will read it after me. A union B is a set of X such that X exists in A, or X exists in B, or X exists in A and B. Oh yeah, Ire, let me hear you read.
A union B is equals to
No,
X.
did I say is equal to? Listen again. Listen again. Maybe that's where we're going to round up. Listen again. A union B is a set of X such that X exists in A, or X exists in B, or X exists in A and B. Where Ire?
A union B is a set such that this is A or X exists in B, or X exists in A and B.
Okay, you tried, but you skipped something at the beginning. You skipped is a set of X. Now, Ezekiel, over to you. Listen again. A union B is a set of X, or you say it's a set of all X, such that X exists in A, or X exists in B, or X exists in A and B. Where? Now?
A B is a set of X existing is or X existing A or B
Now, now you missed something there. You did not pronounce it such as. This thick line or column that you can see there in other cases is pronounced as what?
such as.
So thank you very much. We're going to continue from there. Next class, I'll try to make the notes available to you and also try to make the video available to you as well. So thank you very much. And I hear goodbye.
Goodbye, sir.
See you
Bye.
tomorrow by God's grace.